Let's see now the columnar stores. The key data organization of these data stores follow the column family model. Column family is going to remind you to a table in a relational database, but there are some differences. The table is sparse, and the underlying data model is a mapping from key to multiple pairs of columns and values. Usually stores like this do not care what is a key, what is a column, or what is a value. And we are able to give columns names, and we can do that dynamically. The names can be practically anything. You could often use, for example, timestamps as the names of the columns, and you can have your data models organized in something that is called a long row. So you can imagine, for example, interactions with the customer where you have a key, which is the customer ID, and then you have the column, which is a timestamp, and the value represents the interaction with the customer. And every time when there is an interaction with the customer, you're going to add another pair of the column and the value. Systems like this have more functionality than a key value stores. So we can index column families, but usually it is recommended not to do that and follow the simplest model for our application. We can store complex data, and the rule there is to denormalize. It is accepted that it is perfectly okay to store a piece of data in multiple places. And this is all done in order to improve the retrieval speed of our data. So when you are thinking about the design for your application, you should know what are the queries that you will be having, and then you would organize your column families so that all data that is needed can be accessible without doing any joins. Here you can see some of the most popular systems in this space. One of the systems that we have already seen is HBase, which is the column family database. It's a part of Hadoop. Another Apache project, Apache Cassandra, is very similar in many regards. It is a peer-to-peer system which does not have any single point of failure. And one of the very attractive capabilities of that system is that it has automatic replication even across data centers. And that this capability is there from the origins of the system and not something that was added retroactively. Column family is going to be a good choice where we need great scalability, fault tolerance, and our data model is more complex than what we have with key value stores. The typical use cases for systems like this would include high insert volumes, for example, logging, time series applications, dealing with real-time updates. Many of the systems can expire the content automatically. So for example, when the data gets older than 2 months, you can expire it automatically from the system. Cross data center replication, particularly for systems like Apache Cassandra. And most of the systems would allow you to run MapReduce analytics over the stored data. So merging the capabilities of Hadoop with the NoSQL stores. One of the drawbacks of systems like this, especially if you compare it with traditional relational databases, is that you don't have conventional ACID transactions.